There we go. Oh, and they have, yes, they have all of these now,
Oh, nice.
however this works. Yeah. I'm not going to do that, though. Maybe? No. Cool. I'm so glad that's on video. That's recorded. Okay, we'll give people one more minute and then we'll get started. It's going to be a bit of a lighter one because we've been pretty heads down this month, shipping stuff, but shipping internals. So we'll share a bit of what we've got going on, though. Okay, well, at least it's close enough. Let's get started. So welcome to the March Automerge Community Call. We have a few things for you. Alex is going to give an Automerge update. I'll give a subduction update. And then John may or may not be able to make it, but if he does, he can talk about some massive keyhive speedups that he's been working on, which is pretty great. Without further ado, Alex, do you want to talk about what you've been up to? And you're muted.
Okay, I am trying to find the Zoom screen. Like, it's kind of bizarre. It's
the theme of this meeting is Zoom moved stuff.
no, but it's done an even weirder thing. Like the only thing I can see, like I don't know how to describe this. The only thing I can see is a tiny screen with your face on it. This is amazing. All right, let me see if I can. Ah, right, I have to do that. And okay, right. Can you see my screen?
Yes.
All right, so this is going to be a quick update on a few different bits and pieces that we've been working on. Most things are either small or in progress, but just to kind of surface them. The first one is something that I've been working on today, which is I've entitled here as batch creation, which is extremely obscure. But the problem I'm trying to address here is that when you insert a large in JS, say, if you insert a large JavaScript object into an Automerge document, it can take a really long time because for each node, internal node of the JavaScript object that you're inserting, we have to insert an operation into the Automerge document, which means we seek through the Automerge document to perform that insertion once for every single node in the JavaScript object, which is really slow if you've got a large object. And also just completely unnecessary because each op goes immediately following the one we just inserted. So I've been working on an API to within the Rust library to create a value all in one go, like a structured value all in one go, which is much, much faster. And that's taken a few benchmarks that I've been looking at where inserting a large object has taken like a minute down to like milliseconds. In the JavaScript library, this won't change the API at all. It just means that certain patterns, which could be surprisingly slow, won't be anymore. But it's been kind of nice. That's been something that's been bothering me for a little while. It's kind of nice to just get a fix in. It's on a PR at the moment. Once Orion and I have had a chance to go around it a few times, we'll probably merge it. And then I'll integrate it into AutoSurgeon as well. So if you're using AutoSurgeon in the Rust ecosystem, you'll get all of that stuff without having to think about it as well. Nice. Okay, another thing that we landed earlier this year but haven't really spoken much about is the refs API. I'm not going to go. I think we should probably do like a longer session on this at some point, but I just wanted to show off the docs page here for anyone who hasn't seen it to just go and have a look at it. Roughly speaking, what it allows you to do is refer to a part of a doc handle. and then you'd have an API somewhat similar to a doc handle. So here you can see we're creating a doc handle, and then we're saying, okay, I want ref to just the zeroth to do's item. So that's a reference to this item here. Um, the the reason for this syntax, so you'll notice here the path is like a varargs style argument rather. So actually, sorry, this is a reference to the done field, but it's the path is exploded here, and the reason for that is that that gives you like the TypeScript will figure out that this should be a reference to a Boolean value. We can figure out a way to make the type magic work with an array. Uh, Understandable. As in it's understandable that TypeScript can't do that. And so this gives you this reference to a part of the document, which is useful for a couple of reasons. One is that you can subscribe to just changes to that thing. So if you're rendering that thing in a piece of UI somewhere, you can pass a ref to your component and it can react to changes to it. Um, you can also use the ref to change a value. So again, if you were building, say, a toggle component, you could build a toggle component that takes a ref to a Boolean value and doesn't actually care what document shape it's rendering for. Just makes these things a little bit more reusable. Um, and you can serialize these things and pass them around. So you can, where's a good example of this? Okay, there's not an example in here that makes it straightforward, but you can actually put them in a document and then reload them later on. So you can store refs to say a location in a document and use that in another document to refer back to the original content and maybe store a comment against it using the ref. So this is a pretty new API. Where I would encourage people to break it, find out where it's surprising. But it's already been pretty useful for stuff that we're building. So we'll probably build more stuff on top of it. Um, yeah, okay, refs. Um, Another thing that we shipped this month is documentation for Hexane. So this may be more exciting to people who are more into the internals. Hexane is um, the library that implements the columnar compression that is underneath the Automerge binary format, but which is also used in memory. And this is already a library that we had split out, but Orion's done a bunch of work to document it. So there's a decent usage guide in the README here. And also just cleaning up the API a little bit so that it's a little bit easier to read. So you could use this to now implement columnar encoded data types at runtime of your own. The main reason you would use this over something like Arrow or other columnar formats is that it's good for mutating the thing in memory, whereas most columnar formats out there right now are optimized for like write once and then read a lot. You typically have to rewrite the whole column in order to mutate things, whereas this thing is this span tree type, which you can see the documentation for if you're more interested in, is a B tree of columnar encoded spans, which makes you get log n mutations. Um, Great. And then, okay, Automorph. So this is a library that David Pollack has been working on, which is kind of similar to AutoSurgeon, but so AutoSurgeon is, if you're not aware, is a Rust library for handling getting data in and out of Automerge documents in Rust. It works a little bit like Serde, and Automorph is the same. So you'll see here it's you derive Automorph, and then you can save. So here we've got a person struct which has Automorph on it. You can save that person to a document, a particular key. You can load them out. What's different with Automorph versus AutoSurgeon is it also allows you to do efficient updates without having to do um, the like very deep diff that AutoSurgeon does. And you can also get a diff that's specific to your type. So it gives you some more version control features than AutoSurgeon gives you. Um, this is a pretty new library, but David Pollock has some time to put into maintaining it. Probably more time than I have to maintain AutoSurgeon, and it's already a bit more capable. So if people want to try it and find out where it works and doesn't work, I think if this is useful, then I'll probably start recommending people use Automorph rather than AutoSurgeon. But right now, the job is to go and try it on your project and see if it works. See where there are gaps. All right, yeah, Wasm Budge. this might again it might be more interesting to people who are building JavaScript libraries using Rust. It's a tool that I built here that um, tries to automate most of the work that we do to make the Automerge JavaScript package out of Rust. So it's you give it a Rust library that's built using WAS and bindgen, and then you call this in the root of the crate, and it will build you a JavaScript package that's ready to deploy to npm. And it does a bunch of tricks to make sure that the WebAssembly will be initialized correctly in different places. Um, the whole setup is kind of the whole way that we achieve that is kind of complicated. So I've also this document actually mostly explains how it works, because it's quite likely that you'll run into an issue at some point, and it's useful to be able to understand why. Um, but we've been using this for a bunch of other things that we're building in Subduction and Keyhive, um, and it takes a lot of the pain out of managing the WASM stuff. Um, and then the last thing I wanted to talk about is, so I've been working. Samod is the Rust implementation of Automerge repo that I've been working on for a while, and it's getting more and more. I think it's probably production ready at this point. I will probably start switching it Automerge repo RS over to Samod and saying people should use it. And so one of the things I've been working on is a CLI for that, which so this is the Samod project. I'm just going to show you it has a single command right now, which is samod serve. This is on a branch called samod CLI of the Samod repo, but you can pass it a bunch of listeners, i.e. Local sockets to listen on. These peers are peers that it will connect upstream to. So I use this for running a Samod server that's federating with the public sync server. Like it'll point at the public WebSocket server. And there's some other stuff in here. I'm going to put this in the docs, but the main point is that there's a thing here that we can start playing with. There is a PR out if you want to put any feedback on that PR, especially around things that don't make sense. That'd be useful. It's also I'm exposing a bunch of metrics, and I'll probably release a Nix flake I use for building the metric server that scrapes this thing at some point, just so you can get a decent amount of observability on a running Samod instance. But we've been running Samod in production for a couple of weeks now. It seems fine. It's as good as the JavaScript one at this point. Yeah. Was there anything else on my list? No, that's about it. There's a bunch of ongoing work on Automerge repo. I won't talk too much about that other than to say that it's in support of the subduction work. We're refactoring a bunch of Automerge repo, so repo itself should become a little bit easier to understand as we clear out some of the craft from the last couple of years. There we go.
Amazing. And yeah, just to plus, I don't know, 1,000 WASM Bodge. I put a little comment in the side. I don't know why it doesn't work like this out of the box. It probably should. And yeah, it's Alex previously had like a little script that would do a bunch of this stuff, and that was already helpful. But Bodge just takes a lot of the guesswork out of this stuff, and it's very clear. It's like, I run this once over here. This is how I import it. Like, no more messing around with a bunch of stuff. So it's been like, at least for me personally, it's been really fantastic. The density, just in the chat, the density of cool stuff is impressive. Thanks for sharing. Thanks. Yeah, it's sometimes hard, especially when we're working on this stuff in the internals. It's like, I don't have a demo for you that you can click on, but we can talk about cool stuff. So, I am going to keep rolling forward. Okay, are we back on my slides? Yes. Okay, great. So I've been focused pretty heavily on subduction the past while. Subduction is our peer-to-peer sync for Automerge, so you can both use it directly as a sync server or for direct peer-to-peer connections. We'll talk about that in a second. The current sync server is great. It's gotten us really far, but it does fall over under load because it has to load the entire document, materialize the entire Automerge document and it does that at runtime, like on the request. And so if you have a bunch of people hit the server at once, it's doing all this work and blocking, and large documents can block other people, all of these things. So we did this rewrite also to support Keyhive end-to-end encryption. So this is an end-to-end encrypted, capable sync server as well. So we've talked about this on previous calls, so I won't go into this in like a ton of detail, but under the hood, we break documents up into a data structure we call a sedimentary. It's basically a LSM tree, but for hash-linked data. And so as you're typing individual characters, you get each individual update. And then over time, when its hash hits some metric, so the one we use is the number of zeros, leading zeros, I think, in the hash. That happens probabilistically every, 256 commits. And it'll take that and all of its history up until the next checkpoint, which is 2 or more zeros, so 65,000, right? And turns that into a larger fragment, does the compression that we get, in Automerge on that chunk, on that fragment, and so on and so forth recursively. So over time, we do compaction, but in a way that is equivalent or like consistent across all nodes. And then, over time, these become bigger and bigger ranges, which means we get better and better compression over time. We have 2 sync modes. So we have batch sync. So this is, you're going to start up and you want to say, what do we have that's different? This runs in 1.5 round trips. So we'll just start with the common case. Browser says to server, hey, here's what I know about this document. Do you have anything new? And sends like a little summary. The server can then calculate exactly what the client needs and what it needs, what it's missing. It sends back the data that the browser's missing, plus, hey, I'm missing these ones. And so that's the 1.5. We do this in basically three messages back and forth, and you're fully in sync. So it's relatively lightweight. It's not lightweight enough that you'd want to run this on every keystroke, but it's lightweight enough that we don't think about it when we want to do a full resync on a document, or even to check, am I in sync? And then we have incremental sync, obviously. As you're doing individual keystrokes, you want those to go out to all of your peers and then fan out, and have them forwarded on, so on and so forth. It also syncs Keyhive. So this sedimentary data structure doesn't know anything about the internals. It has a little bit of metadata on the outside, but it doesn't know anything about the inside. So you can compress, encrypt, do whatever you need to do to the payload, and Subduction will sync it. We've also plugged in policies. So you can write arbitrary ones as long as they match a certain interface, but we're putting Keyhive in there. So it'll both sync. It's also pluggable on what you can sync over it, but it'll sync the Keyhive ops itself, and then use Keyhive to determine who has access to which document, who's even allowed to ask for them from the server at all, or upload things. And there is a preview build of that that I'm merging onto main like directly after this call. I'm literally fighting with Clippy right now to like literally what are the order of your imports. But once my import order's done, then that goes in. I just talked about this. So this gives us end-to-end encryption. The server doesn't have to read anything. It can store and forward data. And doesn't have to look on the inside. So you can encrypt stuff end to end, just like how you would encrypt stuff, with Signal or any of these other systems. I'll get to the fast varnish in a second. When I said P2P earlier, so we've also plugged in a bunch of different transports for this. So WebSockets, obviously, because that runs everywhere. We've added HTTP long poll. So if you're in a system that doesn't have WebSockets, or you're running on a worker, in Cloudflare or something like this, you can do fall back to long polling. Unclear if we should do server-side events. We might, but long polling is a good, baseline. mostly because I'm friends with them and I'm excited about P2P stuff. I've also plugged in IRO, which is a peer-to-peer transport over Quick. That's very fast, but it doesn't run in the browser. So if you're doing, say desktop to desktop or, between phones, things like this, then that'll work too. I've been using it to sync my files between my desktop and my laptop at least. So. And Alex is probably going to laugh because I've been giving this presentation a lot the last week, mostly just because I generated some graphs, and graphs are fun to look at. So when we were building we have a custom serialization in Subduction for a couple of reasons, mostly around security with Keyhive and things like, none of the CBOR libraries do canonicalization, right? Which can be a real problem for security things. You can, I get into a whole rant about this. So we just made something that was just like really simple, very straightforward, fast encrypt and decrypt, no generalization, any of this stuff, and that lays out the fields in a very specific order. And that meant that sometimes we need a variable sized integer. So for anyone not familiar, if we want to use 64-bit number, that's 8 bytes. But if I'm normally doing things that have, that are like 100, well, that's 1 byte. So I have 7 bytes that are just zeros all the time. So I want to compress that down as much as possible. So hence variable sized integers. None of the common ones, like leb128 is the common one, quite meet our needs because they have multiple ways of representing any particular number, which is also not particularly secure. People can hide information in there. They can have it deserialized differently on different clients, like all of these things, right? So I took a look at it and went, how hard could it be to write one of these things? And the answer is like 2 hours. So we wrote bijective offset U64 or BZU64. That is canonical by construction, except for the largest of numbers. So it has no more play in the system. You write a number, there's exactly one way to represent it in the encoding and decoding. But this also means that there's a lot less work that we're doing. I had expected this to be a lot slower than the existing things. But I think this is a nice example of make it work, make it right, make it fast. And if it's right, it's probably fast enough. So here's some benchmarks for encoding. Top is my Mac and the bottom is my desktop. We are the green line, and faster, lower is better. So we are the fastest, at least on these machines. Big claims require big evidence, right? But at least currently on these machines. Fastest encoder, second fastest. And as we get bigger, we do worse. And then we have 2 interesting cases. This is when the number of bytes we need increases, is the boundary. And then uniform. Uniform will be biased towards larger numbers, which we'll do worse on. Because if you think about it, the amount of space, if we go from 32 to 64 bits, there's way more numbers in 32 to 64 than in 1 to 2 bytes, right? And then surprising on x86, as opposed to ARM, we're number 1, we're number 2, we're number 1, we're number 1, we're number 1, we're number 1, and by like a pretty sizable margin, which is surprising. And then decoding, we also do very well. Number 1, number 1, number 1, tied, number 1, tied, right? And then basically the same thing for x86. So we accidentally made a really fast variant that is arguably slightly more, has less play in the ways that it can represent numbers. So that's also in Subduction. We are doing an alpha if you want to play with it. What's in there right now? Sedimentary-based sync, batch and incremental sync nodes, all of those transports that I just talked about, both in Rust and WASM, and is wrapped in packages for JS. And Alex there's currently a build of Automerge repo with this in the background. Alex is cleaning up and doing like a proper version. And it's also wrapped for Nix-based deploy. in a repo in InconSwitch called Bedrock, which includes metrics and dashboards and all the usual stuff. If you really want that in Docker, let us know. Putting Nick stuff in Docker is not hard. This is an early preview. Expect things to change. Expect there to be bugs. I'm not claiming this is bug free. I'm claiming that this has bugs. I just don't know what they are yet. So that is where, if anybody wants to test this, you come in. We want feedback on the DevX and any problems that you run into along the way. And especially if there's any other transports you need or storage backends or large files or whatever it is. We want to collect some use cases. And bug reports are absolute gold for us. So please break it. I beg of you. Signing up for the alpha is really easy. You go add speed in the Discord, and then I add you to the alpha. I give you the link. It's not like super secret. It is a public, on the internet URL, but we're just not, broadcasting it at this point. We want to keep it within the community to start. And because I think John actually won't be able to make it, I'm going to give a quick John update. So we're currently in daylight savings is different between the UK and North America. So this is now currently at a time that he's not available. But John's been putting a bunch of time into speeding up Keyhive. And I hope this is on the right tab for everyone else. But basically, we were doing a lot of n-squared work previously. And so he's getting speed ups like 217 times faster, top sorting, which is not bad. So this is the root cause here is when we were writing the original version, I'll take ownership over this one, just put Surdy in and said, yeah, just like derive me some serialization. And then didn't think about it. And it turns out what that does is it walks the entire dependency graph and serializes everything and hashes it as you're walking, doing the top sort. And then you find the dependency and it hasn't cached that, right, as you're doing the same top sort. And so it does it again. And you find that dependency and you will need to hash that, so it does it again. And so we have this n-squared blow up. John put in some caching, and shockingly, we no longer have that n-squared problem. It is relatively, it's not completely flat, but it's a lot better. And even on a single operation, we've gone from 30 millis to microseconds. So some very impressive speed ups John's been working on. And
This particular optimization means that I think at the moment we have a Keyhive sync server that's running 1,000 concurrents, which was not possible before these. I mean, there's still a long way to go before we think it's at like bulletproof scale, but 1,000 concurrents is pretty good.
Yeah. And yeah, that is the material we've prepared for this month. As always, thank you everyone who came for it live. We're going to post the video on YouTube. We will be back at this, same time, same place next month. If you would like to present, drop us a line. We had a couple people that were planning to present originally this month, but then kind of got cold feet and wanted to polish the thing up a little bit first, which is understandable. So maybe we'll see them next month. But if you're working on things, we'd love to see. We'd love to show off what you're working on. And yeah, here's where to find us. And with that, we can move to the discussion portion of this session. But also, if people want time back, it's also fine.
We can build more subduction.
We can build more subduction.
I have a quick question. In a previous session, I'd been keeping up somewhat with the design writing around subduction, just on the GitHub Markdown, and the way the hash hardness let you do the LSM style compaction didn't really click for me until I had watched one of your community calls. and one of your slides gave me the light bulb moment. I don't remember if it was that same session or not, but you had mentioned you could do a sync of n peers in n messages, and didn't have time or a desire to go into it at that point. I was wondering if you could talk at all about what sort of design decisions or technical aspects let that be possible.
Yeah, so it's, I'm trying to remember the exact, we need to write that up. We did work it out on paper, and it does work out. We're not doing it in a ring. It's you have to proceed in a particular order. But basically, because we have this 1.5 round trip protocol, we don't have to. The first message is essentially, like, if you want to think about it this way, is wasted because we're sending the initial metadata across to do that diff and to get things back. But then after that, we're piggybacking all of the data on that message. So each member can send that diff as they collect information. And it's the piggybacking that lets us get that speed up, basically. Yeah, so we don't need to do that initiator step for, if we have 3 or 4 or 5 members. We can just start sending data across, and that speeds things up significantly.
Oh, thank you.
Yeah.
I have a quick question. Alex, so the refs, I'm actually pretty curious. I think it will work really well for just UI elements, right? Did I get that right, that you can like add references to another document into your document, like reference another like ref in a document, and that bubbles like through too?
I'll have to go back and look at the exact API for this, but there is like a serialization step. So you serialize it and say like, I'm putting a serialized ref in here, and then you can reload the ref later on. I think you do need the original document to reload the ref, if that makes sense. You won't just have the ref automatically be live inside of your document.
And there is a method to like just unbind them too, right? Like if you do like UI, like it sounds like it's going to be really easy to turn it into React, like refs or a signal or something like that.
Yeah, they're more or less a signal.
That's what I figured.
Yeah, and we're kind of moving towards signals-based stuff for most of the Automerge repo design. Awesome. Like it just fits really nicely. So
yeah, awesome. Thank you.
All right. Nice. Short and sweet.
Yeah.
Let's call it that.
Great. Yeah. Never going to complain about getting time back. Amazing. Well, thanks everyone. As mentioned before, we'll see you next month. Looking forward to seeing how people use subduction in the alpha.
Good break it.
Yeah. Okay. See you.
Bye.